Uh,
Okay, go ahead. Thank you. Do I use the microphone on my computer? Maybe this is something we should check. You should just be able to talk. Yeah, I am just talking. Okay, thank you. So I'm teaching and I have students and they're learning how to code. And in these lectures, I often wonder about how to have interactive moments, how to increase interactivity with these students. And obviously there's kind of different levels. So level 0 is basically I talk and there's zero interaction, right? Maybe level 1 is that I do some live coding. So I'm still doing all the talking, but they're seeing my thought process and so on. Level 2 is using some kind of quizzes. You ask them questions, maybe show them a small bit of code, and they get to vote on what they think the answer is, or so on. That's good. And then level 3 of interaction is that they actually write some code themselves. You give them a task or whatever, and they have some time to write code. Maybe
you can actually start your video.
What's that?
You can start your video.
So we can video.
Yes, you can video on your.
It's just a blank screen, but it's working.
No. But I'm thinking I wish to see your face.
Yes. So yeah, okay. I can do that. Do you see me? As it says, my camera's on, but I can't see myself. Oh well. Sure. Right. So it's good to get the students to write code, to try to write code during the lectures. But what do you do with all this code? You have 60 students, they've all written their own code. You can't look at them individually. You can maybe pick one out that looks interesting, but I think students don't like that often. So I've been thinking about this. And one idea I got was that students write some code and then we kind of run all the students' code together and to produce some output. And I got this idea of doing it in a sort of competition setting, right? So playing a sort of game where every student writes their own function, which is their sort of submission, their entry into the game. And then we run them all. And since it's a game, we can decide on a winner. So I got this idea when I was on a run last weekend, and I kept thinking about it, and I got home and I continued to think about it, and I said, okay, I'll just sort of code it up quickly and see what I come up with. And I came up with something which I thought was pretty okay. So I said, okay, Monday morning, I'm going to try it out. So there's no sort of research behind this. I just got the idea and tried it. So I'm going to show you now, I'm going to explain to you now the game which I played or designed for my students on Monday. And I thought we could also play it here together. So the game is called Don't Stick Out. So first of all, you need this URL because this URL here, you access it in a browser, you will first of all get a link to the README here, which is a bit more detailed, but also this is where you will submit your responses. The link is also in Zoom. If you want to log into Zoom, just to click a link, but it's maybe easy enough to copy. I don't know, should I make it even bigger? Just that's right. Truncate. There we go. Okay. So the game works like this. I'm basically going to say what's in the README now. You have to write a function which takes in a list of numbers, floats or integers, and returns a single number, float or integer. The game is played in rounds, so we run everyone's function and we get a number from everyone, and then we eliminate the minimum and the maximum and or any duplicates. Okay, those are all eliminated out of the game, and then we play a next round with the people who are remaining, run all the functions again, get new numbers, and keep going until there's a winner. The input is basically the numbers from the previous round, right? So when you run your function, you get to see all the numbers that were outputs for the previous round, and then you can decide what to do based on that. And then the very first round, just get 1 to n, basically 1, 2, 3, 4, 5, for as many players as there are. Those are the rules. Now is your time to think about a good strategy and start writing your function locally or whatever. And when you want to submit it, you paste it here into this editor. So anyone can edit this and anyone can delete the contents of this. So don't do that. Just add without deleting. And then I'll give you, I don't know, 5-10 minutes or something. And then we put them all together and run them and see who the winner is. Don't import anything, but you can assume math and random. So we're talking about Python, by the way. I'm not sure if I said that. Don't import anything, but you can assume math and random. Don't do inputs. Don't try to call anything outside of your own function. Delete files on my file system, access some API, and so on. Obviously, I'm going to eyeball all the submissions first to see if there's anything which is very
So what was the
egregious.
on my phone I can't copy paste the link. So what was the goal of the function? I didn't really get that.
Which link? The one we're
That
looking
one,
at now?
the instructions.
Yeah, I can leave this on the screen, I guess. What?
I just can't open.
Yeah, I mean, I'm kidding, like, it's not working for me. We're not.
Is it a private repository?
Oh, I need to sign in, yeah.
Yeah, you need to sign in.
There's two IAT and Entra.
Okay, it's because it's a private repository. Okay, I can just leave it on the screen here. But I've already said basically everything you need to know. So I'm just going to repeat it for better sake. So you write a function which takes in a list of numbers and returns a number, float or int. And every round, the minimum number and the maximum number are eliminated. And also, if many people answer the same thing, duplicates are also eliminated. So you want to be unique, but not be too big or too small. Okay, and what you get in as inputs, the list of numbers, that's all the numbers from the previous round. Okay, good.
And we need to return one number.
Yes, you're right. If you return anything else, you just instantly eliminate it, basically, including if you raise an exception or.
How do we determine minimum and maximum?
In the normal way.
I
It
mean,
would be.
min and max.
Yeah.
Since they're from 0 to n in the first round, and next round you clean in the. And I mean, like if we also put solutions.
I don't understand the question.
If you have
Well, there are different kinds of numbers.
There are integers and floats, but I'm using the min function in Python.
Okay.
Is that an answer to your
Yeah.
question? Okay.
so you just name your function.
Yeah, they're right. The name should be something unique, which is your name or whatever you want to identify yourself as. Yes.
And which one was included? No.
Random and math you can assume, but you shouldn't import anything yourself. So there's a question. It has to be an integer. No, Nicholas, it can be an integer or a float. Anything else? Sorry, I'm looking at Nicholas Ruberry. Yeah, an integer or a float. Anything else will be rejected.
And does it have to be one of the numbers that you provide? Or
No.
it can be anything.
Yep. So I'll just leave this open to see. Of course, the disadvantage of this is that you can see each other's solutions. We can discuss whether this is a good way of collecting submissions or not, but it's kind of low and low threshold. That is, give people a link and they can just write in it.
Should it return an integer or anything?
Okay, just
Should it return an integer or can it return a float?
It can return a float, yes.
Okay.
Integer or float. So now the way you should. Normally, when I get my students to do some work, I walk around the room a few times.
So we need to name it after our name.
You can name it anything you want, but it needs to be unique and a valid part.
Literally anything.
Average. Is there another question in the chat? See you. Yeah. Okay, when I reach my computer, I will take the submissions that are pasted there and run. So you have maybe 20 seconds left. Do you want more time or shall we go ahead? Yes, no, maybe. We have a bunch of submissions, and that looks good enough to me. So I'm gonna run those. I'm gonna go into my local. That's the wrong thing. Local codes here. Now that's another one. And these are just defaults. Okay, so I pasted them there. Now I need to eyeball them. So the simple example I've got to move. Is anyone trying to do something very outrageous? You need a return here, Robert.
It's not me.
Sorry, explaining to you. So yeah. So no, of course, I normally don't correct the students' things, but to make it more interesting. Okay, but no one's trying to do anything outrageous here, like delete all the files on my file system. So this is probably good.
Niklas says you missed this.
Yeah. Okay. That's not even valid Python, right?
Beautiful.
Math.py. But I'll fix it for you because otherwise you just instantly eliminate it. Okay, so we can run it, I guess. So CDSO interactive. Let's see now. Oof. Maybe I should run it from terminal. I think this will be something a bit nicer. So just give me a second. So this is code. Nope, not that. Python. So okay. Let's see, it's shortcut works. Nope, doesn't. Sorry, I was trying to resize the window. It's very boring stuff. Okay. That's right. Okay. So we already had many people eliminated. Various errors, attribute error. So someone was eliminated for being the max, 4.3. Function call gets a number, and 2 of the functions returns 2, so they're also eliminated. So who we have left? I think is already over. Yeah, that was a bit premature. So what's wrong?
There's some rubbish. So how do I understand?
Now these people all got eliminated immediately.
So what was the problem with mine? I don't have a computer, so I can't.
Yeah, attribute error. I don't know. We can sort of quickly look at it and maybe identify. So
We had a name error.
Brand int or
Oh, I see. I shouldn't use random dots, but
It's not called RAM.
no, it should be
What's it called? Random or
brand int.
uniform.
no, I want the between 0 and 1.
Random.
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 Random dot random.
Okay,
Okay.
I also had RAM. Okay.
Yeah, okay. We'll figure it out. Okay, let's try again.
Can
Okay, now there's only one error. Well, but just show why.
Can we update?
Sort nouns.
It's not called
It's
sort, it's sorted.
Sorted.
I guess also this blank.
But sorted, it asks as if I'm asking whether the list is sorted or
But
not.
this is
Now it's a typo. Nothing to return it, right?
Yeah.
Sorted returns a
Sorted
list.
returns
Yeah.
Sorted returns a list.
iterator or something. So list of
Oh,
sorted.
but then you're adding a number to it.
You have to.
You should just
Oh,
divide it by integrate.
Yeah.
But flows are okay.
No, not we'll be looking at.
Oh, I
these.
see.
But I'm going to be nice and try again. Okay. So there's no errors. So we have round 1. 2 people eliminated here, a minimum and a max, and these are all the people who are left. So now I go to round 2. Another min and a max eliminated. 4 left. Go to round 3. Now we have a winner. So even after fixing the error, it's the same winners. I might. Very good. So I said there would be a prize actually. So first of all, that's Nicholas Blueberry and Nicholas.
Yeah, it's fine.
It's fine. Okay. So then we have one winner in the room. That's Nick. Congratulations.
Thank you. Pleasure as always.
All right, good.
You have just returned pi.
Well, if you're lucky,
The ghost strategy, I guess.
I can run it many times, but it seems to always work. So yeah, it's
Nick also wins.
Okay. Good. So I played this with my students. It went well. I can show you what they submitted actually here. So these are the student submissions. A lot of things. There are obviously lots of or some type errors. Some people were misusing lists. We had just learned about lists, and these are, this is an introductory programming course, so I sort of expect that not all of them would write correct code. But there's a lot of interesting variation here. That people are using random, but people are finding an average and then
increase the size.
Yes, of course. So basically, well, we can just run their code, I guess. And
Are these student submissions?
these are student submissions. Yeah. How do I? Well, I guess. So should just be able to do that, and then so a bunch of errors that basically misusing lists in various ways. A lot of duplicates. Many people just returned the average, right? So that they're removed. Some people removed 0, so on. But we had a bunch remaining, and we stepped through it. It was a few rounds went past, and then eventually we got to a winner. Game 1 was the winner, and the best number was a runner-up. XYZ. But in general, the best solution is that you take an average and then add a very small diff to it, right? So the game is called "Don't Stick Out Too Much." So you need to be unique, but you don't want to be the minimum or the maximum. So I think it was a good exercise. The students understood it. I was worried that they wouldn't understand at all what to do. But they did. I got 32 submissions. There was 10 minutes or so where they could work on it. There was a lot of chatter in the classroom, which I took as a good sign. Yeah. And overall, it was a positive experience, which I think I will try again with these students. At this point, I see that some chat here. Okay. So Nicholas was just asking about why his. So let's see some reflections. Yes, they understood it pretty well, and I think there was some excitement as the students were kind of seeing this round by round who was left and who was being eliminated. The submissions are anonymous, but anonymized, right? So everyone knew which their function was, but they didn't have to sort of put themselves out there. Another reflection I think is that the way in which the output looks in the game is kind of important because you need, you can easily make it in such a way that there's numbers everywhere, people don't understand what's going on, and maybe it can still be improved a lot. But I put maybe half the time at least was put into just the formatting to kind of make it easy to follow what's going on. So as I said, I like this idea and I want to continue it. And yesterday I went for another run and I got another idea. I kept thinking about it, and then this morning I coded up this new idea, and I thought we would premiere it right now, actually. So similar setup in the sense that it's a game and you write a function to play and so on, but the game is tug of war. Okay, so the idea is the following. So the player, all of you are put into 2 teams, left and right. Okay, and everyone gets 100 units of energy to use, and you can choose how to use it. You can use you have 100 total, and you can use a lot, and then slow down. You can use all at once, so you can use always a constant amount. But when you get to 0, your energy is run out, and you can't pull on the rope anymore. And this is done in rounds, and obviously the rope is going back and forth depending on which team is pulling the most. And when all the energy of all the players is finished, then the game ends, and whether on the rope is on one side or the other side, we decide which team is the winner. Maybe that sounds confusing. Let's look at that. So we can really use the same. I had prepared a different link, but I think we should just use the same one. So let me just copy the content of this one to that one. Okay, so there's a new. Oh yeah, but that's not going to work anyway. Close that. Close that. Here's the README for tug of war. So what you need to write is, if I can focus on that, that's good. So you need to write a function which returns a number, which is how much energy you want to use to pull in this round. And what you get as input is the history of the game. So at the beginning, you get just a list with 0.0. So at the beginning of the game, the rope is in the middle. And then if you're winning, if your team is winning, you will see a positive number. And the more positive it is, the further you are away from the midpoint. And if you see a negative number, then it means that you're losing. So this is a history, right? So the last number in the list indicates the current position. And you can look backwards to see how it's gone back and forth. Maybe before we start writing, I'll just show you how it runs. I think that will be a bit more clear, actually. So I have tug of war there. Let me just check. Right, so here I have a lot of basic strategy, which are probably not good, but they're there for testing purposes. There's a lot of failing ones as well. Basically, they don't follow the requirements and they're eliminated from the game. But if I comment those out and run just the good ones, what do we get? So let's see, Python 3, tug of war. Oh, okay, I need to make it not. Somewhere I had right. I want to pause at every round. Okay, good. So the game is about to begin. We have two teams, a left team and a right team, and those, 10 or 20, always 10. Those are the functions, right? The player submissions, and there's 4 players in each team. And now we're about to start we're about to start the game. So in the beginning, the position is 0, and both teams have 400 energy left total, right? 100 per player. So after round 1, right team has decided to pull with 140. Left team has decided to pull with 50. So obviously right has pulled it in their direction to 90, right? Says a lot. So now the position is at this point, which means that it's right is winning, right? But this is how much energy is left for the whole team. We can run it again. So it's continuing to move further right, but by much smaller. And now it's started to move left. So 81 is less than 91. So it started to move left, but it's still on the right-hand side over because it's a positive number. So we can do a few more sort of rounds. Oh, now it's switched over to the left side, right? Notice that the total energy available for the team keeps diminishing. So where is it going to end up? Oh, it's gone back to... No, it's still on the left-hand side, but it's getting close. Oh, now it's on the right. Oh, boop, boop, boop. Now it's on the left. No, it's moving left. Is it gonna... Yeah, so the right team now has run out of energy, so they can't pull it at all. So it's moving in left direction. The question is, will it get negative before they run out of energy, right? It should, I guess, based on the numbers. Let's just fast forward there. Yes. Okay. So the left team wins. So at the end, the right team had totally depleted all their energy. They couldn't pull anymore. And the left team just needed to slowly drag it over 0 until they won.
It's the division of teams, I know.
Yes.
But I don't understand. So you move by the difference of the energy that you spend.
Yes.
So that means in total, both have 400, so they should end on 0.
No, I was thinking the same.
Yeah, that's what I thought too, but it not to be.
A magical word of floating point.
Yeah, I think. Well, basically, I think this is the explanation for it. Another way of getting around it is that you add a factor, right? So if they spend, let's see, if they spend 50 and 50, then it's 0, it doesn't move. But if they spend 150, then the distance is 50, but you can move it by 50 times 1.5.
I think what you want is some kind of collaborative thing that if all in the team give the same energy, then it's multiplied in some way.
Right.
But if one gives a lot and another one gives a little, then it's not as good. So in some cases, maybe you multiply, or I don't know, but you award if they have an even spread of energy.
Yeah, that's one way of working it out. Yes, I think then these functions that need to be implemented also need to have that information. So the teammates need to know how hard that.
No.
The players need to know how hard their teammates are playing.
No.
Yeah, obviously there are many ways which you can sort of evaluate. This is a good point, which kind of was my initial instinct, but in reality, it doesn't work out to be that way. I think it's basically down to to floating points, arithmetic and round, right? So let's try it with your own submissions now. I don't know if the instructions were clear enough. So in the same Rustpad thing here, I've pasted some simple examples. So you get the history, as I said, a list of positions and energy, how much energy you have left.
As a team.
No, as a player. As an individual.
Every player was 100. Okay.
Yes. If you return anything larger than energy, it just gets capped, and yeah, once you're down to 0, then you can't do anything basically.
Okay.
So I'll give you another 10 minutes to think about it.
The same.
For this,
Yeah.
and then we'll run it and see what happens. I can leave this on the screen. Same things about before. You a function with a unique name. You can assume math and random. If you throw an error, then your energy is just set to 0 immediately, and you're kind of up the game.
What if you throw? Oh, okay.
If you throw an error of some kind, would you benefit a?
Robert with Niklas. No, Robert.
What is below the in addition point?
What's that?
It ends up with in addition, I assume.
Yeah, it says the things I already said verbally. That's if you. No, it's yeah. I think the thing about the imports, the thing about what happens if you throw an arrow. I'll scrolling and show you when I get to it. No, I don't think it's anything which I haven't already said.
I think this this is a good exercise anyway, even if the result is only 0, because that's after a while maybe some of the students will realize, well, it doesn't matter what you return, because in the end the team will only expend their 400 and it will be and so on. So it doesn't matter.
Yeah.
And that's also something you could discuss afterwards.
Yes,
why
indeed
you did all these very good implementations, but they always seem to be plus minus 0
yes
in the end. Why? So I think it's a good thing, because it's because there's a bad class. It's a good exercise, because you can discuss it afterwards. And then you could perhaps discuss how could we make this game more interesting. And so.
But so how are we doing? Let's check what submissions you have. Guessing you want some more time, but if otherwise.
What was the requirement on the output?
It's a number, right?
And
it can be positive or negative.
Yeah, that's a good.
If you return negative, it will be 0, and if you return something higher than energy,
So,
it will be energy.
This, of course, can be up to the students to think about. But I can tell you that I don't check for negative values, but you'll basically be helping the other team, right?
But will you increase your own energy for later then?
Sure. Yeah, I think so, actually.
So then it evens out in any case.
It could be infinite, right? I guess.
Yeah.
If you alternate between a negative.
Oh, there's a loser.
Let's see. Let's see. What do we have? Oh, we have a lot. Okay, I'm gonna. If anyone has something which I haven't put in here, then please do it now. That's okay. You can do so. In the meantime, I'll just eyeball them and see if there's anything. Lazy. E beats pi. eBay. Okay, pi times 5 minus 100. Yeah, let's see what happens. So fun. So there's rounding which happens somewhere. So this will just be treated as a 0 basically. Are you done now, Nick?
Yeah.
Okay, good. So let's paste them.
So the history, is that your personal history? No, that's the position.
Position, right. And I need to add my imports, don't I?
So Nick, your agent will pull harder when you're winning,
I suppose so.
and when you're losing, it will help the other ones. That's it.
Is this valid in Python or does it need to be like that? Don't try to know. So I think in this game the errors are not reported as clearly, so we might not necessarily understand.
It's a lowercase and then.
So the weight is here. Okay. So we look exactly 14 submissions, perfect. 7 in each team. Always half, be lazy corrected, Peter something. Okay.
Yeah.
So it's 100 each. Let's see what happens. Oh, okay. Oh, what's happened?
Yeah, the loser always returns -100. So I think the one in the losing team will lose.
The one. Yeah. So okay, let's go on the other way now. Look.
The left hand is gaining
Now it's positive. It's gonna be hard to get out of this one. Although, look, that's now we have. I don't know, we have 100, but we still have 1500 there.
Because the loser always gains.
Yeah. All right. Yes. So is this going to? No, yeah, this is never going to.
No, I think we can remove the loser.
It's fine. I think yeah. So the negatives probably need to be handled. Although if the student thinks of that, I should be kind of proud of them.
Competitive against the framework. I like that.
So, how does it look now? We're still on the right, but we're moving left and right again. Looks like it's impossible for left to win right at this point. Oh no, but this is also increased. Yeah, so somewhere there's a. I mean, it's
You
not
need to be lazy because that's also gets the incorrect.
we can also just not accept negative numbers in the actual source, right? It's a better thing to do. So let's put back loser. Let's see where my you're gonna have to excuse me when I put here. So E given, right? So yeah, let's say if E less than 0, E given equals 0.
Yeah.
So that should be enough to eliminate this problem, I think. Okay, let's see what happens now. 7 in each team again. Well, it looks pretty balanced. I'm not sure which way it's gonna go. It keeps moving in that direction though. Now so it's just
left 2 points.
so yeah, so now the left team has basically given up, even though they have energy left. And so yeah, so this is not going to exit the whole time, right? So so I think we shouldn't allow 0 basically as a result. Okay, let's try that again actually. So let's say something like this. It's actually more than that. I need to set the energy for that player to be 0. Something like this, right? I don't know. It doesn't look. A quick attempt, it won't be right, but hopefully it will avoid. Okay. Yeah. Well. Yeah. Okay. We hold it. Left width. So this was interesting to watch. Although maybe the individual student feels less sort of proud of winning or losing because first of all they're randomly assigned to a team. Secondly, even if you do something really good, if all your teammates do something bad, probably make a difference anyway. So that's a possible problem with this game. And then I have other ideas. That's basically all the code I'm going to show. But so this was tug of war. I was thinking we could have one which is rock, paper, scissors, basically, where players they play head to head, and the players can see the history of the other player. So if that player plays rocks a lot of times, then I should play paper, right, or something like this. Although I'm not sure it's possible to come up with a really smart strategy, like more than that. This I've written the code for, but I'm sort of, yeah, I'm not sure it's a good idea. And another one I thought of is like a stock market kind of situation where the students can buy or sell basically stocks and the price can go up or down. And then at the end, you can see who's made the most money. I've actually heard my students discussing stock tips during the break in my lectures. So I think they might like something like this. And this I think is maybe easier to implement, or not to implement, but easier to to define what winning is and so on, right? But I haven't written any code for this. It's another idea. And then did I have another one? Yeah, a kind of validation game where maybe you supply like dates in lots of different formats, and they need to correctly pass them or correctly reject them, and the more they get, the more points they get. For it's more boring. It's definitely a useful task to be able to do, input string validation. That's it. So I'm happy to hear. I mean, there's already been a number of suggestions about how these ones can be improved, and maybe you have ideas for totally different games. Maybe you've seen other such games being used. As I said, I did not research this at all before doing it. I just did it. But I'm sure other people are doing similar things. Maybe someone here knows about that or not. What do you think about any of it? Yes.
Yeah, one thing is, I mean, you were talking about that maybe this algorithm is working correct or not. I mean, doesn't really count if the game is implementing the logic very concretely or not. The point is students are getting involved into it somehow. Even if there are a bit of mistakes, like getting stuck on zero or some other minor rule-based problem. So still, the thing is it works.
Yeah.
But the other thing is, I mean, all these activities, they are somehow what I can, understand. Maybe that understanding is incorrect, but I have seen that they are mostly targeted at understanding functions and understanding these numbers, integer and float. For the first example, by the way, it was a very good example of understanding the imprecision of this float mechanism. So, do you plan to extend it to other, topics, or have you thoughts about it? For example, how can we make such a game in which students are making such functions which give them understanding of, say, dictionaries?
Yeah. So
it's a lot. Definitely, it's a large way to go to design entire work.
No, absolutely. So the examples I've shown are all basically about lists and floats, let's say. Another obvious thing is classes, right? If you tell them you have to implement this class with this function, and then they can have an internal state inside of the object, I think that can be useful. So, for example, in this tug of war example, I give them their remaining energy as a parameter into the function, but arguably they could keep track of that in a class, right, in an object. Of course, then so that's one thing which I think is definitely doable. Obviously, other data structures like dicts, I don't have an example off the top of my head, but it shouldn't be. I'm guessing that, or I'm imagining that a situation where the players need to keep track of what other players are doing, then I think would be important, right? In some way. And maybe this rock, paper, scissors thing can be implemented that way. So if I know that player X, always throws scissors or something, I don't know. So yes, absolutely. How much to connect it to the other topics in the course is wide open. But those are the two obvious things I could think about.
For example, during this discussion, I have got this vague idea, for example, again, which involves a simple game which involves some kind of bookkeeping. So it would have, an attribute and its value. So would demand the implementation of a dictionary, for example, we'll talk. But definitely, a long way to go to think about all those topics, and but it's really, it's very very
Thank
good.
Sorry, yeah, I didn't.
Actually,
Yes.
yeah. So I think the idea is fantastic, and then then the difficult part is to come up with good games that are on the right level for the topic and that don't take too long time, and so on and so on and so on. And also, I think the infrastructure needs to be fixed so that people can't destroy, like make things too bad in some way. You said here that you're not allowed to have input, you're not allowed to have this and that and so on. But maybe if we want to have this, then should be some checks, like that people don't do that. When it comes to, so one thing is that you can read what others implement.
Yeah, because they're all in the
Yeah, exactly. I think that doesn't have to be problematic. Could be, but at the same time, yeah, why not? It's just a simple game, so you could be inspired from others and so on.
Yes, I mean, I could.
One thing that you can't check if you do this is if some function calls another function.
Yeah. No, I have to eyeball them to detect that kind of stuff. I mean, I could, if we wanted the submissions to be, private, then I could set up like a submission in Canvas. But already that feels like too much overhead for the students to have to go.
I think this is great. That it's very easy to just get started, do something very very quick, and you can do it within a lecture. It's 10 minutes, and then you see them. So it's perfect. But the problem is to find these good games. I think the first game was really good. The second one could be good. It could lead to a very interesting discussion, but we have to fix the outliers in some way, and so on. But there's, as Mustafa said, if you want to have something for dictionaries, yes, but then important thing shouldn't be too complicated. It should be something that you can implement in 5 lines of code at most. And still do something interesting. That's difficult, but it's worthwhile to just start some kind of repository where all the teachers could add suggestions to this is a task, this is a good task, and so on, which you can reuse. I think that's perfect.
I think Nick wanted to say something. No, sorry. Yes, now as I'm here thinking about it, I would like to do one which involves them implementing a class, basically, because they will need to learn basics about, defining classes and so on. And I think it's quite natural that you have this idea there where there's a player and the player has a sort of internal state, which is, all his previous moves or whatever, and that can be used as part of the game. So that seems like the next thing I should try to. The next game should be involving that, because these students will soon learn about the basics of classes. Right?
Auctions, perhaps.
Yeah.
There are auction robots, and there are even algorithms for good auctions and so on.
Yeah, so everyone can start off with the same amount of money, or whatever, and then there can be some number of items which are for sale, and the winner is the one who has the most items at the end for the same amount of money. But so if you spend too much money on one item, then you won't be able to buy many more. I don't know. Possibly.
What I think of, if I need to develop, I would rather start it from the other side. First thinking about what is the current topic to be delivered today. and then try to find or maybe generate a simple game idea. And that can go to a little complexity later time in the course where students are, comfortable with basic ideas. And then at some point, instead of putting their individual submissions, they can group in the class. They are already in groups. They can work in a, because this will then bring this peer instruction also into it.
So I suspect that, in my class, like when I ran this game on Monday, I got 32 submissions, and there are at least 60 students in the class. So I suspect that they are working together to some extent.
Yeah, that is.
And that's something which I chose not to be specific about. I mean, they could choose to do one each. They could choose to do many each, or one per group.
I think that's the right way. You shouldn't not in like a classroom setting, shouldn't force students to do it in one way or the other.
Right.
So one thing I thought about is you can also think about not having competitive but collaborative race.
That was
The war was a little bit collaborative, but you could have like you want to do agents that in together complete something.
Yeah. So what I was thinking of is maybe something like navigating a maze, or something like steering a ship, like through a narrow passage or whatever, where of course it's very slow to react. So the students need to steer together, but it will overshoot and then they need to correct. But this is a very abstract idea.
It's a nice idea. Yeah.
But I agree. I would like to have something which is not competitive, which is purely collaborative. Yeah. Good. So thank you for coming and thank you for participating. I think I got the result which I wanted, right? Which is that there were submissions and we ran them, and it was kind of a little bit exciting to see what happened. And sure, there were some problems along the way. Some of the basic, about importing and naming and whatever, and some which were, little bugs in my code, edge cases, whatever. But I all think that's part of the process. I don't think that's bad. We got to do those together. So I'm happy with the way it went on Monday and with the way it went now. So I'm pretty sure I will continue doing this in the future. Excellent. Yeah, thank you.